Quadrilaterals, weird stuff, part two. So what we're talking about is uh, this quadrilateral stuff. This is the stuff that whenever we were talking, we had already covered. And I think it's just a really good idea to constantly remind yourself of these things. So one thing that can help find the degrees in any quadrilateral, any shape, any triangle, anything basically other than a circle, um, is this formula right here. So you take the number of sides the shape has, and then you take 2 away from it, and you multiply by 180. So if you did that, this is a pentagon. Pentagons have 5 sides. You take away 2 times 180. That'll give you 3 times 180, which gives you a total of 540 degrees. To find the measure of each angle, all you have to do is divide by how many angles there are. That'll tell you how much, and that's going to be 108. And you could always check that by adding 108 up 5 times or multiplying it by 5. This is just the formula you use to find out the amount of degrees inside of a shape. That's going to become relevant soon. This is the kind of self-talk that I was constantly prompting you through. This shape has blank sides. That makes it a blank. What type? Why? So here's an example. This shape has 3 sides. That makes it a triangle. What type? An isosceles triangle. Why? Because 2 sides and 2 angles are congruent. How many degrees does it have? It has 2 congruent angles and then 1 acute angle, and it's going to end up being 180 degrees. Got it. And basically, if you cover all that stuff, you've identified it from the most broad to the most specific and talked about its attributes. You're basically defining the shape. The thing that you were struggling with the most is a trapezoid, just identifying it. You're pretty good with rectangles and squares. Check, check, check. Just know that when there is no label, we're calling that irregular. Trapezoid, these little triangles right here, they mean that those sides are parallel. All right, those are called the bases, and then the things on the side are called the legs. The distance in between bases on any shape is always going to be its height. So the rhombus versus the parallelogram. If you have trouble spelling it, paradouble-L-E-logram. Parallelogram. So knowing the difference between a rhombus and a parallelogram, and I always suggest starting with understanding a parallelogram and then finding the slight differences in moving to a rhombus, and then moving from a rhombus to a square, or moving from a parallelogram to a rectangle, and then moving from a rectangle to a square. There's a diagram I'm going to send along with the video. Just to summarize this again, we know that it's a quadrilateral. 4 minus 2 times 180 is 360. We know we have 360 degrees. If you were to add all 3 of these up, you'd end up with 260. Well, how the heck are you supposed to find out what's left? Just subtract it. That's how you find out what's left of anything. 100 degrees. So just know that you can always add all 4 of those angles up, and you should get 360. It'd be easy to logically troubleshoot your way through that if you were to forget what you're supposed to do in that process. So moving through this, these are the big 4 for a parallelogram. And this is where understanding these 4 items are absolutely critical to what you need to be able to do. Opposite sides are parallel. So I'm going to mark those real quick. I'm just going to use little arrows like that. And then these opposite sides, you can see they're parallel as well. Opposite sides are congruent. So we know that those are equal and those are equal. Opposite angles are congruent. So we know that and that, this and this. You can see how I'm labeling this. If you're able to label the parallelogram and know what these symbols mean, then you're knowing the big 4. Diagonals bisect each other. Okay? Know those four, be able to draw and read that diagram. So let's talk about a rhombus. All four sides are congruent. Boom, bam, pow, get it. Diagonals are perpendicular. Opposite sides are parallel. You're like, hold up, this looks almost exactly like a parallelogram. Yep, except for the all four sides are congruent. Okay, opposite sides are parallel. You can see I'm still using the big four from a parallelogram, but we're going to add in the other stuff that makes this a rectangle. Opposite sides are parallel. Opposite sides are congruent. Tell me when I'm wrong. Just kidding. Opposite angles are congruent. And that holds true still on a rectangle. Diagonals bisect each other. Check if I could draw straight lines. Then we know that we have four congruent angles. Not only are the opposite angles congruent, but we have four congruent angles. And we have two pairs of parallel. And opposite sides are parallel. These two go hand in hand. Four congruent angles is what's going to make it the rectangle versus the parallelogram. What is a square? A square is everything we just talked about. So let's go through the big four. Opposite sides are parallel. Check. Opposite sides are congruent. Check. Opposite angles are congruent. Check. Perpendicular bisector. Check. Now all we have to do is throw in all angles are congruent, all sides are congruent. Then we threw in the attributes that came from a rectangle and from a rhombus. Check, 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 check. What? One more check. Get some. And this is the diagram you have got to know. So this is where it all starts from the parallelogram. Know the big four from the parallelogram. And then know what's different if you move to a rhombus. Know what's different if you move to a rectangle. Then, once you know what's different from a rhombus, make it into a square. Then once you know what's different from a rectangle, make it into a square. If you're able to differentiate between those, all of those in that order, then you're definitely going to have an understanding of basic geometric figures and their properties. This is something that I'm going to send over as well, that I feel like if you were able to complete this with any type of accuracy, the benefits are huge to being able to identify these things. Just know that square is going to have the most. Okay. So just to go through one of these, we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. 10 minus 2 times 180. That's 8 times 180. 8 times 180. Heck, I don't know. 1440. So interior angle sum. Sum means add. So if you added all the angles together, you get 1440. Well, what the heck? How am I supposed to know the interior angles? These little dudes. I know there's 10 of them. So I'm going to divide this beast by 10. And I'm going to get 144. That's how much every angle is on the interior. Interior means inside. You made a great point whenever you said, hey, is that this one? Am I looking for that? No, but we do know supplementary because we know a straight line makes that. So if we know that this one's 144, how the heck are you going to figure out this one in here? Well, you know it's an acute angle. It looks awful acute because the other one's obtuse. Supplementary angle, acute plus obtuse. So 180 minus 144 should give you 36. So each exterior angle is going to be 36 degrees. it would be okay to practice these. I mean, you could just hypothetically go about and create, like say you've got an octagon, do 8 minus 2 times 180, divide it by 8, then figure out what the interior angles are, and then write down what the exterior angles are. You can do that over and over and over for any amount of sides.